One of the most famous equations in physics by Albert Einstein, E equals to mc squared, states the idea that anything that has mass has an equivalent amount of energy, and everything that has an energy has an equivalent amount of mass. In other words, mass is a frozen energy. This idea is called the mass-energy equivalence. Einstein's equation says that object's rest mass multiplied by the speed of light squared is the object's rest mass energy. Rest mass is the mass of the object at rest, and rest mass energy is the energy that an object with the rest mass contains. If the mass of the object increases, its energy also increases. This means that mass and energy are just the same thing, and you can change from one form to another. To prove that mass and energy are interchangeable, let me explain a concept in nuclear physics: mass defect and binding energy. We all know that the total mass of an object is the masses of its components combined together, but that doesn't work in making up the nucleus of an atom. Always the mass of the nucleus is less than the mass of its components, protons and neutrons, combined together. And this is how. Suppose that these two water bottles are two protons. The mass of a proton is 1.00727647 atomic mass unit, or 1.67262219 times 10 to the power of -27 kilograms. But if you combine these protons, will it make up the mass of two protons? The answer is easy. It is no, because this is what happens when two protons are combined. When they are combined, the two protons lose mass. This mass is called the mass defect. It is converted to energy, and to find the equivalent energy of this mass, we use E equals to mc squared. So the more energy that is being produced in the process, the more mass that is being lost. And in case you heard that the sun is losing mass, this was the process. The sun changes some of its mass to energy by a process called nuclear fusion, and the product is called mass defect or binding energy. Almost everything in this universe has a mass, but why don't we change those masses to energy? Well, we don't know an effective way, but believe me or not, we will find a way, just like we saw what we once thought was the unseeable, the black hole.